Okay. Long time no see. Um, Better late than never. Never late is better. No better time than the present. I have a lot of physics to go through. I don't even want to look at how behind I am, but took a little break because I was very behind in school. Very, very behind in school. But now we're not as behind. Majority of today is going to be doing some physics because I have some physics research that I need to, our physics research scheduled in the fall with a professor from my university. And I need to get all the way to classical mechanics. So we're just going to start over from the very beginning. And I think it should all work out because I'm taking physics 2 in the summer. I was going to take it this semester, but there's a lot of logistics going on with that, and I just couldn't do it. And then I'm going to see if I can take like a AC/DC circuit analysis course as well this summer. We'll see. Hopefully it all works out. But as of right now, this is what we're going to do. We're kind of going to speed through this a bit because I'm pretty aware of what's going on here. Majority of my pitfalls, I think, will come from, I think this will be fine. I think it may be once we get to like conservation of energy in a system. Maybe not though. And then maybe like linear momentum. I think the biggest thing for me with physics is okay, like I know how to apply formulas, but then it becomes when we have multiple axes or coordinate systems that we're working with, and not only do you need to apply, I don't know, the spring constant in the x direction, but maybe we have to apply it in the y direction too. So then we have to set two equations equal to each other or just something like that. That's where I'm like, okay, you lost me. So I'm not sure how much of this will be able to get done. And then my plan is I have a chemistry exam on Monday. Right? Yeah, it's due Monday. And I need to start my chemistry homework. And I have a differential equations exam probably on April 3rd. So we kind of need to lock in a bit. Yeah, I think that's pretty much it. Today I'm actually going to wear the mic to like talk through what I'm thinking as I'm doing this. But first I have to do something. Okay. I'm gonna clean up, but before I do. Okay, you can't see the board. Okay. Hope I don't get claustrophobic. Okay. Alright, things I have to do. Hopefully this doesn't come out inverted too. Not really a fan about this. Okay. Hopefully you can see. Okay. I'm probably gonna do like a 5-hour session. I would like to stop at 6 p.m. and then go get my dinner. Or go exercise again. Okay, so we'll split this up into math, physics, and chem. Okay, so talking about looming deadlines, I've got exam 03 on, I think that said March 30th. I've got my homeworks 18 and 20 also due on that day, but then also I need to go back and redo everything from chapters 16 and 17. What does this all come out to? Death. This would mean that I need to go through the OpenStax, or not OpenStax, these are OpenStax, physics and math. I'm using a plethora of resources, to be honest, but I'm using Tro's chemistry book, chem textbook. Okay, I need to go through chapter something and chapter something else. And to be honest, if I don't redo homework 16 and 17 for chem, I'm just gonna go through and do the problems. Oh, that's what it is. It's chapter 16 and chapter 17 plus EOC. EOC is end of chapter problems. So I'll put like end of chapter preset. And then I think that should cover, because my class is based off of the infamous Tro textbook. So as long as I go through the chapter, I feel like that should be like suffice. I'm not gonna lie. I don't think I should have to do much more than that. Okay, and then that's Tro. I think that should be good. I think that's all that's needed from me for chem. I do believe I have one more. Holy moly, I knew this was gonna be claustrophobic. Let me see. I don't know what that looks like. I think that'll be fine. You're not gonna be able to see chemistry, but tough cookies. Low-key so much going on over here. Let me see. Why is it like this? Okay. Piggybacking off of that, I think the only thing I have left, yeah, I have this galvanic cell discussion post, which I think it's gonna be fine. That should be open now, I think. That's usually how it goes. You have like one discussion post, and then once that one discussion post ends, she opens the next one. I'm not gonna lie, I've been doing horrible in general chemistry. This is Gen Chem 2. I've just been slacking. Tragically. This might be my worst semester. Schooling wise, I'm not gonna lie. I just want to do other stuff, you know? Like, I just really don't care for, like, structured learning. That sounds so bad. But right now, I really just don't. Like, I just want to, like, learn proofs and do more physics, and I really just don't. I'm kind of sick of, like, the gen eds. Even though these are my last ones. General chemistry is my last one. I think differential equations is just, when I sit down and take the time to do it, it's calm. It's calm. Introduction to program, don't even get me started on that. Oh my gosh. Okay, and then if time allows, then we can go through and do the galvanic cell discussion posts early, which I still might. Also for astronomy, as you can see, there's my unit 4 test, but there's nothing but discussion questions left, and then that's the completion of this course. That is something I definitely want to get done today and just have that, like, completely off my plate. So I'm thinking I work pretty diligently for 2 hours, take a break, and then complete that, like a small brain break, and do that. And then kind of shift gears and do something else. I think that works. Differential equations. Can't even tell you. Haven't been to class in God knows how long. But I like differential equations, even though I haven't been to class. Mind you, it's online. Crazy. So we'll see. What the heck? Crazy work, but my professor's leaving, like, in the middle of the semester, basically. Okay, so I'm not gonna write descriptive astronomy. I already have it in the back of my mind. I know what I have to do. Differential equations. I would like to get some proof work done today too. If at all applicable, I really would like to do that. For physics, let's just go through, we've already gone through chapter 1. I would like to finish chapter 2. Plus the end of chapter P set. And then I would like to start chapter 3. The difficult part about this is no matter how much you enjoy a subject, like burnout takes no, like, prisoners. Like, burnout doesn't care. I think that's kind of what's difficult about this. Is I don't want to do too much too soon, too often, because then I'll burn out. But it's hard though, because if you really love a subject, you want to do that subject all the time. I don't know. What? Well, let me do this too. For my, I did all of this. For my habit tracker. I've been trying to track my habits just because I feel like it keeps me accountable. And it helps me, like, notice little stuff that, like, otherwise I wouldn't have noticed. Like, in the middle of every month, I have, like, this hiccup. Like, in the middle of the month, I have, like, this hiccup right here. Where I don't know what happens. I just go rogue. But that's good to know. I wouldn't have noticed that if I wasn't tracking these things. And I think it's like a cool dopamine hit when I get to highlight the boxes. It's pretty fire. And I've been doing this since the beginning of January. And then at the very end of the month, I kind of take a percentage for each habit And if it's above like 90, then sometimes I do away with it. Sometimes I keep it and just say, oh, good job. How much battery? Oh, Jesus. I did this. I gotta remember to do physics problems every day too. And then I read today my physics book by Shankar. And I gotta do some math. Yeah, today's been pretty solid though. Sometimes I focus on it, sometimes I don't. Sometimes I'm okay, I need to do this, and this. But sometimes it just kind of naturally happens, which is good. I mean, that's the point of a habit. I also need to start reading this, how to solve it. A lot of stuff to do. A lot of papers to read too, not gonna lie. But yeah. I also have a physical calendar, but I don't know. I actually will use this. I'll write down the stuff in here too. That's not gonna work. Okay, this book is really good. I know I'm like geeking out. This book is actually pretty fire, I'm not gonna lie. I just started reading this like last week. I don't really read. Yeah, I don't really read science fiction, funny enough. So I want to start reading it more, and this is pretty good. It's pretty good. Okay. Hold on, I'm missing 2 imperative things. This speaker that keeps this here. I just feel like I have no space to put anything. I swear. And I'm missing my charger. All right, I think I'm good. Math, my math goal today, plain and simple. If I can get caught up, not plain and simple. I'm just gonna review my Putnam Prep chapters that I went through for proofs, and then I'll couple that with the, I think it's Vellman proof text on sets and logic, and then I just need to get caught up in differential equations. Don't even know where to start with that though. What the hell is that? Yeah, we'll see how long this takes. Might take a minute. And then huge goal is to finish AST 1000 course. Okay. take so long to get started? It's so funny. Oh, let me look at this too, because I'm taking my test in person. So I gotta see how that's gonna work. Oh, and then oh, okay. Okay, so that's something I need to do too. Contact one of them. All right. Okay, let's start. Yeah, I'm not gonna be able to access these. Kind of sucks, but I think it'll be fine. Okay. I have hair all over my screen. All right, time, velocity, speed. Velocity versus time, given a graph of position versus time. Interpret. Okay. By the way, if I highlight it in red, it's like super duper important. If I highlight it in blue, it's supplementary important. Like, it's good to know, but okay, elapsed time, difference in time, beginning time, T sub F. I like putting T sub F minus T sub I for initial, but sometimes like a good bit of people do it like this too. T naught, which makes sense because it's time at x equals 0. That's where it comes from. So it makes sense. Yeah, literally what I just said. This reminds me of, darn, when we, oh my gosh, there's no way. I just know what it looks like. I'm so sorry. It's like, this and then this and then we chop it up into small, tiny pieces. I should know what this means though, right? Blah, 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 blah. This is calculating area under the curve. Yeah. It's area under the curve. Whereas change in x gets smaller. We learn more, we get a more accurate representation of whatever that area is under the curve. Yeah, infinitesimally small intervals. And then once it gets so small, we basically get our instantaneous velocity. I think it's as it approaches 0. What is it? Instantaneous velocity? Is that where velocity approaches 0? Or what is velocity? Instantaneous velocity is the average velocity at a specific instant in time or over infinitesimally small time interval. To get smaller, we're going to have to approach 0, so I think that's where they're going with this. But taking a limit, calculus operation. Yeah. Now, when it says a calculus operation beyond the scope of this text, I'm using the algebra-based textbook. And then I'll go through and I'll use the calculus, or I think OpenStax has a trig based. I could be entirely wrong. And then I'll go through and then I'll use the calculus based. But I want to make sure I understand how to do this process algebraically, trigonometrically, and then calculus wise. My course this summer is calculus based. This course that I took in the fall of last year, Physics 1, was calculus based. So, yeah. I'm interested to see how we're going to do this, though, if we're not going to... I guess we just won't find precise values then, because precise values requires us to use calculus, taking the limit. Speed is a scalar, though. Yeah. It has magnitude, but it doesn't, yeah, no direction. Okay, so instantaneous speed is the magnitude of instantaneous velocity. Oh, and we know when we take the magnitude, it's basically like, I think it's this. Yeah, so then this would basically come out to like, we would be taking negative 3.0, squaring it, which would give us a 9, and then we root it, and then we get a 3, which would be our speed. That makes sense. So that's how we would get instantaneous speed. Instantaneous velocity is 40 kilometers per hour due north. Instantaneous speed would be 40 kilometers per hour, same magnitude but without a direction, because we know speed doesn't have direction. Average speed, however, is very different from average velocity. Average speed is the distance traveled divided by elapsed time. So, but that's velocity, so this can't be it. Oh, so average speed can be greater than average velocity, which is displacement divided by time. Yeah, which is this. Oh, because total distance was 6 kilometers. Average speed was 12 kilometers per hour. The only way I could see that is if we did using a keep change flip, then I could see us getting 12 kilometers. But this isn't, oh yeah, this would be 1/2 of an hour. That's what I'm thinking. 1/2 of an hour is the same as 30 minutes because it took, you went to the store and you came back home in half an hour. This is where I think we're getting this from. But displacement is 0, which makes sense because, oh my gosh, I keep getting hair on my screen. This one's stubborn. Okay, home, store. Okay, and then let's say the total distance traveled was 6 kilometers, so that means 3 kilometers this way in the positive direction. Assuming that this is 0, by the way. And then to return back, negative 3 kilometers. So then 3 kilometers minus 3 kilometers, 0, net displacement. And that's how we get displacement for the round trip is 0. Hey, copycats. Oh, Jesus. I struggled with these. I'm not gonna lie. The position, time, velocity, speed, time graphs. Oh my gosh. Freaking struggled with them. Probably still do. We'll see. Probably still do. Okay, when it's like this, like if someone just asked me what is the position at time, like 0 point. Actually, let's do this. I think this is, oh wait, no, is this? Yeah, like we'll just say this is, they asked me for position at time 0 point, I don't know what that is, like 0.25. Okay, because it's asking me for position, and that's something that we have, we would just say it's 3. You just read the graph. But what I've learned is, let's say they asked me for the velocity at time, let's do something simple. Let's do velocity at t equals 0.5. If I'm not mistaken, I would do basically position, we know velocity is just change in x over change in t. Oh, I think I would have to give 2 coordinates. No, maybe not, because if I just do final position is 0.5 minus 0, or would it be 0 minus 0.5? That's where I say I think we need to go from one point to the next. So like velocity at time t equals 0.25 to 0.5. But either way it goes, you're basically going to take change in x over change in t to get the velocity if it's a position graph. If it's a velocity graph, again, if they ask us for the velocity at here, if they ask for the velocity at t equals 0, then velocity is just equal to 10 kilometers per hour. You just read it off. Same thing here, but then the opposite way, darn, this is gonna be funky. If they ask for the position from the velocity, that's where we have to apply calculus. So I'm interested to see how we're gonna do that with algebra. But we're gonna have to, basically what we did right here was take a derivative. Change in one variable over change in another is a derivative. But it's algebra. So that's gonna be fun. But if we wanted to know position from this velocity graph, we'd probably take an integral. Because, I mean, we know that the integral of v is equal to the position function at that same time. Yeah. Pretty much. That's what I'm thinking. Oops, I didn't mean to do that. So, we'll see. And then speed, remember speed is just magnitude. So it has no direction. And it starts at 12 and it seems to stay at 12 for 0.5 seconds. What is this? Average velocity, we have to do change in x over change in t, which would be 40 miles. Now, I would probably convert this to minutes, yeah, which is what they did. Oh, and back. That's why this is times 2. So this would be our 105. That's why this is 80 miles, because we have to account for it coming back. And then this is miles per minute right now, but it'll be miles per hour. And then this is our average velocity, which, yeah, this is average velocity. Now, what is this down here? Oh, I see what they're saying. Just kidding. Average velocity is 0 because it goes right back here and then it comes back. So what was I thinking of? Average speed? Was I thinking of average speed? No, I was thinking of regular velocity. This is regular velo. That's what I was calculating up here. Average velocity is different though. Yeah. Yeah, average velocity is different. Okay. average velocity is 0 because x of f is equal to x of 0. And we know that because it goes from Baltimore to Washington, D.C. and back. This is the key, the and back. Average speed, though, is miles per minute. Oh, so this is average speed, and then we just put it into the units of speed, which is meters per second. Okay, acceleration. I'm assuming this means the same thing though, because average acceleration, if average acceleration is the same going one way and the same back, then it's 0. Yeah. To check something like this, usually when I do problems, I do like a units check. This is kind of small, low key. Might be. Why does it look like this? Am I tripping? I'll do like a units check. That looks a lot better. So I'll do like, oh, we're taking meters per second divided by seconds, which is the same as meters per second divided by seconds. Keep, change multiplication, and then we flip it 1 over s, meters per second squared, which is acceleration. I'll do something like that, just so I know I'm getting exactly what the problem asked me to get. Okay, yeah, meters per second, which is meters per second. That's how you would express that. Recall that velocity is a vector. A change in velocity can be a change in magnitude or speed, but it can also be a change in direction. If a car turns a corner at a constant speed, it's accelerating because its direction is changing. The quicker you turn, the greater the acceleration. So there's an acceleration when velocity changes either in magnitude or in direction or both. Acceleration is a vector. There's a chart I remember where it like told you which ones were vectors and which ones were scalars. I don't remember where to find it though, but I do remember that. This is an interesting topic as well, because some people don't say, oh, there's something else people say. It's like it's not deceleration, it's just a negative acceleration. Yeah, literally, right here. Yeah, negative acceleration in the negative direction in the chosen coordinate system. So this is actually what I was talking about verbatim. So deceleration is the process of slowing down the object or the particle. So the object, let's draw a car. This object or particle is moving this way, and then the deceleration is kind of bringing it the opposite way, where this would be like the brakes. Whereas, and then let's also define some coordinate system where this is 0. Okay, but then to piggyback, negative acceleration is something entirely different, because negative acceleration is the car moving in the opposite way, I guess you could say, relative to your axes. So now in this example, 0 is going to be in the middle, and the car is going to accelerate. Well, it's a clunky car. The car is going to go this way, which is towards the negative x direction. I should probably put that. There's no brakes involved yet. There's no brakes involved yet. But this is negative acceleration. All right, dude, you'd think I wrote this textbook. Yeah, like this is this is deceleration, where this would kind of be the brakes. This should also be deceleration. This is negative acceleration versus positive. Yeah, positive acceleration, negative acceleration for B. Decelerating, opposite to motion, towards the left, negative acceleration. Yep. Pretty much. Okay, now we're looking at no freaking clue. What is this? Oh, okay. So change in t is equal. So we're looking at negative 150 divided by 1.8 seconds. Meters per second. Now, find the change in velocity. Am I tripping? No, I did it right. Yeah, but if it said average acceleration, that'd be a different type of question. So the negative sign here, they're saying, indicates that it's going this way initially. And then it's going to the left In 1.80 seconds is the time that we want to figure out what's going on in this time period. It's still moving backwards, so there's no like brakes applied. Yeah, okay. And then there's instantaneous acceleration, which I believe occurs as this also gets infinitesimally small. Yeah, this is literally the question I want to know. How the hell are we going to do this with algebra? Okay. Okay, change in X. Just be positive. Okay. Change in V is just equal to 30. Yeah. Change in A. Oh, I'm just kidding. I was about to say, am I not going to have to take this from kilometers per hour to like meters per second? That's what I was about to do, which is exactly what they did. Okay. As long as I'm on the right track, I'm not going to, what's it called? I'll save like my brain energy for working the problems out for the end of chapter stuff. I'll just wait. No, it's just more examples. Okay, we're getting near to the end of chapter. Oh, and I see velocity remains constant, 20 to 40. Okay. Looking at a change in x, which is equal to, yep, negative 1.50 kilometers. If it takes 5 minutes, oh, average velocity. Well, we know average velocity is just equal to, or actually, yeah. Or am I lying? Is that just velocity is equal to change in x over change in t? Average velocity. No, I'm right. Okay. So then, yeah, over this 5.0 minutes, but we're going to need to transfer this to meters per second. So, convert the units. Kilometers, and we know 1 kilometer is equivalent to 10 to the third meters. Oh, that's right. We can do meters per second or kilometers per hour. I had to remember that. It'll probably save me some time when I'm doing this dimensional analysis, not having to convert so far out. So we can do meters per second, kilometers per hour. I think there was some more. It's like centimeters per something. Okay, subway train. Okay, now we're doing constant acceleration. When there's constant acceleration, if I remember, velocity is equal to 0. Because there's no change. It's just the same acceleration. Right? I think that's what happens. Yeah. And I think in the same way, when velocity is constant, I think acceleration becomes 0 too. Is it that when it's constant, when velocity is constant, or when velocity is like instantaneous? I don't remember. I don't remember. We'll see. Okay, so 3. Oh wait, am I tripping? Oh, just kidding. Oh yeah, they took it to seconds. And then the seconds canceled out. Oh, there's another here on my screen. Jesus. So now we're going through derivations. And this is the equation for final velocity. Now, would this be, it's decelerating, so is it a negative 150? Hold on. I wasn't going to put the units, but I will. Because then, oopsie, we get this comes on 1, and then we get it's actually going to be minus. I keep getting stuff on my iPad, my God. 1.5 times 40. No, I just get 10. But does this make sense? That the final velocity of an airplane who's coming in with an initial velocity of 70 and it's decelerating at this speed for 40 seconds. Yeah, I think that makes sense. Makes sense. I gotta start like, I think that's like another sanity check, like making sure it actually makes sense, that you're not just being delusional. This is where we get this is the full mamma jamma, which we got from taking the velocity, and then the hell? Adding v naught to each side of this equation, dividing by 2. So they said they added v naught to each side of the equation. When they say they're adding v naught, are we taking the v naught expression? What do we mean by adding v naught? I mean, I understand this because v is equal to v naught. Well, but why are we, unless, take the integral. Oh. What am I doing? I could have just took the integral. Yeah, this algebra is interesting. To get the position function, I could have just took the integral of all of this with respect to t. That's such a funky way of writing it. And then I would have got v naught of t plus 1/2 a t squared equals x, because we know that the integral of v is equal to x of t. And then we would have got the same answer. What? How did they do this using algebra? It's got to be plug and chug. That's the only other, they're not going to use calculus, so it has to be that they plugged in something for this, or even this. Because we haven't solved for t yet. I don't remember us talking about solving for t yet. So it's got to be one of those. This is what I'm thinking. Yeah, see, they even said they're going to substitute for average velocity and substituting that into this. Oh, I see. Oh, wait a minute. So I'm guessing they basically took this and put that here. That's what I'm thinking, because then that would give v naught plus v naught plus at over 2. But then that would give 2 v naught at over 2. Why would we do this? That's interesting. Yeah, that's we're gonna come back to this derivation. It's kind of funky. Dragsters can achieve average accelerations 26.0 meters per second squared. Suppose such a dragster accelerates from rest. What this means is that v naught is equal to 0. Right? Yeah, there's no initial velocity. And they're going at this rate for this much time. How far? So we're looking at displacement. Or just x, whatever you want to call it. X is equal to v naught t plus v, oh wait, wait, am I tripping? Or is it just v naught? Oh, but there's no, I think it should be fine because there's no final, it doesn't give me initial position, so we can just take this and subtract it over here, and then we'll just get change in x is equal to v naught of t plus 1/2 at squared. We can just do that. Okay, so from here we get that it travels basically 1/2 26.0 5.56 squared. 1/2. Let me put the units. And how we know we're correct, because these should cancel. And then we should just have this times 26.0 times 0.5, and it moves a distance of 402 meters. I rounded. Actually, let's go to the, I gotta remember sig figs. So let's go to the first decimal spot, which is 401 point, would be 9. That's what I got, 401.9, or we can say 402, which I think would be better for distance, for displacement. We'll see. They drew a sketch. Yeah, they did 402 meters, which is fine. I like to erase this stuff too, because when I come back and review this, I would like to go through like the same process again. I kind of don't want to see the answer. So sometimes I accidentally do see it, but solving for final velocity, yeah, this is where we get this one. This one is good too because it doesn't involve t. It omits t. And then some square roots end up being taken, but calculating the final velocity without using the information. Oh, same thing. Acceleration was 26.0, total distance 402, and then velocity 145. And these are super important, like the holy grails for kinematics. Position, average velocity, oof, that's funny. Regular velocity, given acceleration, average velocity, position, given velocity, position, initial position, or you can move this over here and we would just have like this change in x equals v naught. Basically the problem we just solved. And then this one is our velocity using omitting time. So that's that. Now we get into problem solving. Yeah, this is what I struggle with when there's like several unknowns and you've got to use one or two of them to get one of them to use in another equation. This is super important to make sure it makes sense. You know, if it's calculate the, I don't know, displacement of a swimmer swimming from here to the local, I think it's called like a buoy, something like that. It's not gonna be like 50 miles per hour. But if the question was like calculate the displacement of a boat, then that makes more sense. But no human is swimming 50 miles per hour to the nearest buoy. Like, maybe Michael Phelps. He's pretty goated. Yeah. I think where this is going to become increasingly important for me is in situations or scenarios where I'm not really sure of the, like, I don't have a deep understanding of it. So, like, for instance, anything that has to do with, like, physics 2, like that whole electromagnetics, electronics, capacitors, diodes, AC/DC circuit analysis, like, I've never touched that before in my life. And so it's kind of like, how do I know if this is a proper ohms value, or is this a good amount of amperes given, I don't know, a lamp versus a boombox, or a TV versus an iPad, you know? How much energy should these things take? I have no clue. Yeah, this is a super important. I actually was just, as I was waiting for my boba, I was going through some of Shankar, his, because Shankar has a, right? Wait, hold on. Shankar has a physics book, right? He does. I know he does. He has the principle. This is not what I'm talking about. Please, dear God, no. I'm talking about this one. His Physics 1, Mechanics, Relativity, and Thermo. I'm going through this book, and dude, there's this one problem literally killing me. And it's like free fall. So like, we have this building. We toss up this object. And it comes down. And this is like Y max. And it's, yeah. There's just multiple steps involved. Which again, we're kind of getting used to doing. But what I do like about falling objects, you're really only working initially because the problems are like so elementary. You're only working in like the Y direction. Unless they ask you like displacement, then you're working in the X. The only time I can see X and Y is like throwing a football. That's where I like see that happening. Yeah, gravity. And so usually when you're approaching falling objects, your acceleration is gravity, which helps. So it's just your negative 9.8. Or I've noticed a lot of times people just estimate it to be 10. Like that's what Shankar does in his book. He just estimates it to be, you can just assume it's 10. I did not know that. I thought it was always 9.8. This is actually super important, defining directions, especially with gravity. If we're throwing an object upwards, gravity is going to go opposite of it, so it's going to go downwards. If we're throwing it downwards, then gravity is going to complement it. Gravity almost wants everything to fall. So if I'm dropping a pencil, gravity's like, ooh, yes, let me help. So it's positive. If I'm throwing it up in the air, the gravity's like, no, I don't really like that. Like, let me push it down, negative. So, and then there comes that point of time where if I do throw it up, that's what I was talking about with Shankar, because if I do throw it up, there's that point where its velocity, the initial velocity that I threw it up with, becomes 0. And at that point, it changes direction and it'll come back down. And then that's when, again, that's where some problems say to break it up into 2 sections. The initial, like, throwing the pencil up and then the falling down of the pencil, because gravity is kind of 2 different values there. Gravity is negative as I'm throwing it up, it's going against the object, and then gravity is positive, it's like, oh yes, fall, you know, on the way down. But there is a way where you can keep it all in one, I think. Maybe not. Maybe not. Maybe not. I could have sworn Shankar said there was, though. Maybe not. One-dimensional motion. Yeah, this is, you change your you change your variables to that of y and g. It looks better in my opinion too. Visually appealing. Because when your brain thinks of x, you're so conditioned throughout school to think of x as like left and right, and y is like up and down. So I think it just goes well. Yeah, see. So then position, we can do like change in x is equal to 13.0 meters per second, 1 second. It's thrown up. So this is again, let's do 1/2. negative 9.8 times, and this would actually be x of 1. So 13.0 meters, 1/2. We'll just do it like this. I gotta start learning this value too off the top of my head. Negative 9.8 times 0.5. And this is how I can tell I've done something wrong, because this is meters and, oh, no I didn't. I just forgot to cancel out my units. So this is V naught of t. So now we just have 13.0 minus 4.9. So the position is 8.1 meters. That's what I've got for, oh, sorry, I just did that again. Oh, that's right. I should have kept it. I shouldn't have done change in watch. Look, I'm so accustomed to changing x. It should have been y sub f, which is our final, with y sub naught, y sub, yeah, y sub naught t plus 1/2 gt. Is it 1/2 gt squared? Yeah. So then, oh, yeah, because if this is, wait, I might have goofed. No, I'm right. This just becomes 0. No, I'm right. Okay, I'm right. What did I get confused on? I thought I forgot about initial position, but I guess this is the initial position, or no? Oh no, it's just telling us where the rock is at this time. And we know at y naught, so when time is equal to 0, it's basically still in the person's hand. So this is how we know it could be moving up or down. And then we would have to calculate v1. To do this, I would probably just take the derivative of the position function. Yeah, that's what they did. I just take the derivative of the position function and then do the same thing all over again and just plug it all in to get that. This is also something I learned in Shankar when I was looking at that problem I just described a few moments ago with like finding the max of the building. He just took the derivative of the position function to find the velocity and where, so he found the velocity at that time, and I think he did something like he found the velocity, or he solved for velocity at 0, because again, when like your initial velocity runs out, that's like the peak. It reminds me of like when you take your second derivative in Calc 1 and you figure out whether it's, and then you plug your values in and you figure out whether it's positive or negative, and then whether it's going upwards or downwards. That's what it reminds me of. Oh, it's a bummer. Okay. And then, yeah, so from here we see it's going upwards and then it's falling downwards. And because this is negative, this just means that it's falling below where we threw it. So we might be standing on something. Because if that's the case, it would be like we're standing on like this platform. And then we threw this object up. And then this was it at t equals 1. Okay, and then this was it at t equals 2. It was still positive, and when I say positive, I mean we're assigning this to be 0, this to be the positive y direction, this to be the negative y direction. And then that means that here, where t equals 3, it was negative, and it fell below. I think that drawing models are super helpful too. I low-key think about it and I'm like, when I get to topics like topology and stuff like that, how the frick do you visualize a n-dimensional manifold? The frick is that? Like, what does that look like? No clue. But, yeah, and then position over time, velocity is decreasing. It starts at 15 or 13, somewhere in between there, initial, and then over time the velocity decreases, and then once it hits 0, now we kind of have a, once it hits 0, we've gone from the, I guess, like human-centered, whatever, human-initiated velocity to like now the velocity that's coming from as a part of gravity. Acceleration over time. This one is interesting because yeah, this is exactly what I was thinking of. And if it's this situation, v naught is equal to 0. There is no initial velocity. There's only final velocity to be calculated. But in this scenario, we have an initial velocity. We have some sort of, not like human interaction. It doesn't have to be human interaction. It could be a catapult too. But we have something initiating the force. Here, we're just letting gravity do everything. And then this is where, like, that v naught becomes equal to 0. Like, we no longer experience it. And then from here forth, it's just acceleration doing the work. My picture was better. Hell no. Yeah, pretty much the same things. And you're just kind of plotting it on the graph. Okay, graphical analysis. We're at the end of chapter problems. Good grief. Oh, there they are. Okay. I was about to say, I've been here for decades. Oh, this is another. Oh, we just solved for acceleration due to gravity? What the freak? This is no different from when it was x. Oh, my bad. When it was x minus x naught, by the way. But we're just doing it in the upwards direction. So we took this and we solved for a, and then now we've calculated our acceleration due to gravity. All right, now graphical analysis. independent, dependent variable, independent, dependent. This is the independent variable, and I'm learning that now from differential equations, which I should have already known it, but you know what? It's fine, don't judge. When two physical quantities are plotted against one another in such a graph, independent variable, vertical axis is a dependent variable. M is the slope. We know all this stuff. Time is usually on the x. Okay, and then the slope, which is the change. So change in x over change in t is our slope, otherwise known as this, average velocity. Change in x, this would be our change in t, x naught. Yeah, that checks out. The slope of the x versus t, so this means we basically do change in x over change in t, but hold on. Calculate the velocity at time 25. Oh, so in this situation, actually, this is we would actually do this and this, because it's going to be the average, and then it will end up giving us this. So we would do 29 minus 1500 divided by 30 minus 20. 29, 15, and then divide that by 10. So then it would be 140 meters per second. That's what I'm going to say, yeah. At first I was like, oh, we'll just calculate it here, but remember you need 2 points because change in x is x final minus x initial. This is no different from if we had like 2, 4, 6, 1, 2, 3. If we wanted to find the average of all these numbers, we would do, let's break it down the middle, we would do like 2 plus, if we wanted to do the average of these numbers, we would do 2 plus 4 plus 6 divided by 3, and we would get whatever is like in the middle. Consider this like the middle. We're doing the same thing here. We can't, I guess, explicitly go and calculate 25, but we can use the numbers around it to calculate it. Because average is just if you take the values surrounding, like if this wasn't here, we would still be able to find or approximate for that. I hope that makes sense for me. Maybe. Maybe not. Okay. Fire. It's clicking. It's coming together. Motion of the ship based on its velocity. Starting at this initial velocity, it has a constant velocity, and then it basically changes directions. And I'm assuming this means it's changing its direction in the negative, yeah, decelerating. And then decelerating even more. This would mean that the acceleration graph would probably be, oh, I see, constant, and then constant for a little while longer. Okay. What's the next chapter? Two-dimensional kinematics. Fun. Okay. Well, it took like what, an hour? 30 minutes. It took an hour and 20 minutes. I'm actually surprised I stayed locked in for that long, not gonna lie. All right, I can cross that off my list because I finished, and now I gotta do the P set. Now I gotta do something like calm, so I don't kill my brain. What is calm? Okay, hold on. Okay. So. I gotta hurry up before my brain turns into mush. That happens. I don't think I want to start on these problems yet, though. I kind of want to go do something else and then come back to this. But it's gonna have to be something calm, because if not, my brain's gonna die. I'm gonna do some. I'm gonna do some of my Astro discussion posts for like 20 minutes, I guess. All right. Okay, so now I was able to get 2 of them done, which is pretty good. I was able to get 2 of them done plus the replies. So I just have to do lesson 13, 14, and then I have to take my Unit 4 test. Pretty good progress so far. Okay. Now I'm gonna lock in. Take my Neuro gum. I'm not gonna lie. The beginning taste of these is, I think it depends. The wintergreen one is, it's you know, just in case I ever get sponsored, I can't say anything tragic, but it's you know, it's, well, you know. But it's okay. Bro. Alright. And then for my chemistry block, we're going to go through chapter 16 plus the end of questions in chapter 17. And that should prepare me pretty well. I think that should prepare me pretty well. I also need to honestly, I had to email the professors to see when I can take my Does this mean that the rest of the semester is like self-led? Actually, hold on, because I kind of need to call my school too. Yeah, I kind of need to call my school. Let's do that. We have like a call queue line. So tragic. Don't even get me started. And I gotta figure out what I'm gonna eat today. And then I actually have a good bit of stuff to do, I'm not gonna lie. Because I also need to see if I can get into this electronics course I want to get into. And apparently they say you can take it as a co-rec as long as you've taken physics, which I have. Oh, I did not mean to do that. Oh, shoot. Probably thinks I'm a freaking intruder. All right, let me see. Yeah, because right now I had to put the lab on there, but I don't plan on doing the lab, not gonna lie. But May 18th to August 10th, I have physics 2, physics with calculus, mind you. Tuesdays and Thursdays, 6:30 to 8:40. Oh wait, just kidding, that's the lab. From 3:30 to 5:45, and then the lab is 6:30 to 8:45 p.m. on Tuesday. Tuesday is gonna be such a long day. Such a long day. But that's what I'm saying, like, I don't, and I really, I'm not just gonna sign up for a class just to be considered full-time. I can't do it. But I really want to take that electronics course. I think it's like EET. Yeah, AC circuit analysis. And it's at the Palm Beach Garden. But I think it overlaps. Because my course session is, what did I just say? Was it 3? Yeah, like this is Tuesday, Thursdays, but it's 2 p.m. to 4:40. And then, and I think this is the one I would have to take. I think this is the one where the co-rec, yeah. Mind you, there's only one person in the class right now. And then this one is Tuesday, Thursdays over here by my house. It doesn't make sense. Like, this is me. My physics course is up here, like in my state. But the electronics course is, if I'm here, over here. Like, do the math. The hypotenuse is a squared plus b squared. It doesn't even make sense. But that's when I said the other thing I can do is, yeah, and I'm not going to be able to do that. But this is, like, not going to lie, the only course I would actually consider taking. The other thing I could do is take general physics. I don't really want to. But I could take, yeah, and I'm not going to be able to make this. Oh, it's 3:30 to 5:45. Yeah, I don't know. I just need like one more course. Hold on, let me go get in this. Ding dong. Q. Bruh. What time is it? It's freaking 3:48 on a Thursday. What the freak? Dude, an hour? I'm not even... And sometimes it's like, I wish they had descriptions under these too, because even after you click on a service, it's like, is that really what I need? And then they get upset with you when you're in the wrong service line. Like, I'm sorry. What the hell? Let me write down my question, because sometimes I get nervous and I start choking. So what do I need to ask? Yeah, and full-time in the summer is like what, 6 credits? Huh? I'm sorry. Let me look at this again. They said, this thing says that full-time is 12 credits. There's no way. That's not even, that doesn't even sound right. If that's the case, I'm going to take this at another school. I mean, that's not why I'm taking this at another school. That doesn't make sense though. College, taking 12 credits in a summer semester? That doesn't even make sense. I thought it was 6. Yeah, 6 credits. Dude, what the hell? Yeah, that's what makes this a little bit difficult. And then the other thing is, I'd have to find a school. If I take this somewhere else, that's cool, that's fine. I would just have to find a school that then I gotta go and apply my FOSFA. But it's fine. We have what, March? I have like a week left of March. April, May. So if I don't take it in person, I'd be taking it online. I'm not crazy about online courses, I'm not gonna lie to you. But I would just have to apply my, I just have to apply my FOSFA to another school. Okay, so if that's the case, that's perfectly fine. I would actually prefer a course where I can do, God bless me, physics with calculus 2. And a school where I can do like a higher level math. Physics with calculus 2 and lab 5 credits. And then I also have to make sure that the tuition is, I mean, it doesn't really matter because I'm a Florida resident, so. Oh, okay, yeah. Okay, let me add this. This is online, semester based. Oh yeah, let me look at their course catalog. Let me see. $394. Okay, so let's go to like 400. Okay, yeah. Or I could have just did the Control F and just searched. Or is it Command F on my computer? And did physics. Whoa, that's a lot. Okay, I think I got it. No, I don't. These are the minimum requirements for what Where the frick am I right now? And they all say conceptual physics. Okay. Where the frick am I? Oh, I think I'm in... No, I've got no damn clue. Where the frick am I? I'm in early childhood education. That's fire. No, okay, I'm in electronics engineering technology. Oh, this is perfect. So here's their physics course with the lab. Bro, freaking computer programming in C. I don't know what's worse, C or Java. They're both ass. Literally cannot stand them. Okay, wait, what is... Okay, so they have digital fundamentals in lab, microcomputer, advanced electrical circuits in lab, analog. I probably want to do this one, this introduction to electrical circuits in lab. I need to keep that in mind. Not gonna lie. Okay, then my next question is how high does their math go? Because I'll either take a physics course or I'll take a math course. It just depends on whichever one is higher. So most likely they have calculus. Yeah, they have calculus. So Mac 2, 3. Okay, what major is this? Okay, good talk. Yeah, but this isn't really helping, I'm not gonna lie. I just kind of want to know how high up does their math go. I think it might just be calculus 1. Calculus 2. Might just be calculus 2. Oh, but they have thermo. Oh, but this is all engineering, EGN. Okay, let me do MAT. Oh my damn. Okay. MAT mathematics. Alright, let's see what we got. Oh, it's not a lot, guys. It's MGF, MHF. Wait, what am I at? MAT? Okay, wait, let me scroll up some more. Because MAC is math calculus, which I just want like a proof course. I am so much better taking courses when it's structured. I can self-learn things, just yeah, maybe not. Just takes a little bit. Calc 2, okay, they've got Calc 3. They have discrete math, which that might be the move, I'm not gonna lie, discrete math. Isomorphism, graphs and trees, this might be the move. This is basically proofs. This is proofs, sets, and logic. Not offered in the spring and summer. That's what I love to see. I love that. It makes my heart happy. It's fine. Okay, this is apply. There's your differential equations, but I've already taken that. Oh, here's linear algebra. Oh, with some exposure to proofs. Oh my gosh, they have abstract algebra. Oh my damn. Oh, my heart is happy for all this time. Oh my damn. Are they for real? But when is it offered, bro? It's only offered in the fall. Bro. Oh, number theory though. Number theory is offered. Number theory is offered in the fall, spring, and summer. You just have to have taken MAC 2312, which is just, I think that's just Calc 2 for this, right? MAC 2312, Calc 2. So I could do number theory. That could be a vibe. That could be a vibe. Number theory. Why can't I do abstract algebra? Like, okay, I think number theory could be a vibe. I think number theory is the vibe. Yeah, this would be like, okay, so I'm thinking, that's fire though. Okay, and then, all right, now let me try this, because what did I just say I wanted to take? Because then I can just look it up. Yeah, I wanted to take, I don't think I'm gonna be able to take abstract algebra, I'm not gonna lie. But number theory, or I just said it. It was in MAS, I think. No, it was, yeah, MAS, which is down here. Oh, MGF, no, I need MAS. Oh, I was in MAS. No, I need MA applied, whatever applied is. What was I talking about just earlier? Wasn't it discrete math? MAD, you dinkleberry. My bad, pimp. MAD, yeah, discrete math. Okay, let me see if I can do discrete math. What's this school called? Bro, they don't have it. Oh, let me do for the summer. That would probably be, oof, advanced discrete mathematics? Don't think so. No, probably not. What's another thing? Let me make sure that this was for, yeah, exactly. I freaking knew it. That was for the, I gotta make sure this is on the right stuff. I need this for the summer. Lake Sumter? I don't know how to feel about that. That sounds fishy. I don't know. Oh, people like her. Oh, people think she's goated, actually. Oh, no, like, actually, people like her. All right, bet. But again, the thing is that this would mean that my classes all have to come from the same place. You can't like split up. You can't split up financial aid. So now my institution is gonna have to be like somewhere. And we just pray that they have some math courses. Okay, now we're in the maths. Yeah, this is not looking good. Why is it doing that? You would think it would go from like alphabetical order, but no. Okay, this is okay, subject. That's what I should have done instead of sitting here. Physical sciences. Oh, but we already have a science. So, oh, here we are. Okay. College algebra. Oh, we love college algebra. Oh my gosh. All right. There's nothing. So that's fun. Okay, let me try something else. Let me look at engineering. We're gonna have to do a different school. I love that. I really do. We're gonna have to find a school that has both. This is like actually insane in my opinion. Actually insane. Okay. Let's do it like this. Subject. Let's start with math. Physics 2 is going to be easier to find. Usually, pretty much every community college has Physics 1, Physics 2. It's the upper level maths that they typically don't have. Let's do... Would it be graduate credit? I don't think so. Advanced probability and inferences. But then this will be good though, because if a school is offering graduate credit, they probably have a pretty good math department though. Applied combinatorics, capstone, discrete math for teachers. Okay, so it's... Oh wait. I've actually heard great things about them. So we're gonna go to University of West Florida. And hopefully they have it. I think I'm still in math. Okay. Advanced Calc, biostats, capstone. Am I still in the graduate? Jesus, no, I'm not. Wow. Capstone, differential equations. Please throw me a bone. Elements of statistics. Not gonna lie, push comes to shove, I might take something like that because statistics actually and probability in general is very important in quantum mechanics. Mathematics for data science. Multivariate methods. PDEs. More PDEs. Topics in combinatorial theory. They are indeed not throwing me a bone. Indeed, they are not. Yeah, this is... Okay, try it again. Delete the institution. And then let me look at this. Like, why is the freaking call queue like this right now? Oh wait, there's 0 people in line. They either got through them all or they literally like just called them and hung up. Because if I'll do undergraduate credit. Okay, it's at least giving me calculus 1. Advanced calculus 1. Oh, there's advanced discrete mathematics. Hold on. I just want discrete mathematics. Please. Okay, Eastern Florida State. Hillsborough, FIU. Okay, now we're gonna try Hillsborough. And we're gonna take this out. And we're gonna look into what just happened. We're gonna look into Hillsborough, even though I was already kind of looking into Hillsborough before. But we'll see. Okay. I could have just went and looked at the course catalog, but we're already here. Oh, there it is. Discrete mathematics, summer. Do they give me any more detail than that? Okay. So now I kind of want to go look at their course catalog. It'd probably be under engineering. Oh, they have a math and science department. Okay, they have a mathematics pathway. And that's it. Okay, let me just get to the... Oh, it's in... Oh, Jesus. Oh. Okay, let me try... Where is the catalog? And then let me type in mathematics. Okay. Okay, let's see here. So it would probably fall under MAD, which is discrete math. And then they have to have some sort, well, I'm not going to say they have to, because then they'll disappoint me. MAD. Okay. Some aspects of discrete mathematics: logic, set theory, graph theory, functions, relations, computer arithmetic, and elementary combinatorics. Yeah, that did not give what it should have gave. That's fine. Okay. Let me look at this pathway. Okay, I might take basic AC/DC circuits. Solid state devices, microprocessors, solid state circuits, photonics, linear integrated. They have a good bit of electrical engineering though, which is so interesting. I'm not gonna lie, but okay, but this is just, and they don't have any more math courses. Let me try MAP. Yeah, they have physics with calculus here as well. Okay, what is this for? The computer science pathway, of course. Okay. See, I've already taken, and they don't have any. And to an extent, I'm kind of willing to sacrifice. Like, if I can learn elementary number theory, frick it. Oh, that's UNF though. Or FGCU. Or if I wanted to learn abstract algebra. Okay. Discrete. What the frick is discrete math 2? Yeah, this is gonna be fun. How long have I been doing this? Bruh. Oh, let me... Bruh. I didn't even put myself in this stupid call queue. Okay, now let me mute myself just in case they call. Bruh, 12 credits is full time. It's okay. It's cool. It's cool. It's cool. At least I know how much, like, I get to. Let me make sure. Let's do the math, because I'm in state, so tuition's like $101. Let's say a course is like 3 credits max, right? So my total Pell divided by that. Oh, okay. Okay, now let me do some more math. Now, if I'm taking... Oh, that's like... Okay. Okay. Who would do this to themselves? Who takes 4 courses in the summer? What the freak? Okay, that's what I'm looking at, though. All right. Balls to the walls, boys. Balls to the walls. Okay, then low key, I might as well go big or go home, because how much is... I might as well just go to freaking UF. Am I tripping if I say that? If I just go to UF? Like, I might as well. Bro, Bro, what are we talking about? Let me do the math. Oh, actually, it's like... Bro. And that's a fire education. All right. Oh, shoot. Dude. Bruh, did I get into UF? Let's go. I've been checking this to the point where I was like, bro, like, all right, maybe I just didn't get into UF, bro. Frick it, whatever. But no, literally yesterday. Literally yesterday. Dear Aspen, congratulations on your admission to University of Florida. Let's go. You must receive the Associate of Arts degree to remain eligible for admission. You must complete additional program requirements. An AA degree is required to remain admissible to this major. Hey, yo. Let's go. But I'm only transferring for 1 summer, so. Hey, that's kind of goated, though. Let's go. That's kind of lit. If that's the case, then I'm not gonna lie. I'm just gonna take my courses at UF Online. Like, UF Online, like, physics courses are... Bro, no way, don't piss me off. Oh wait, this is like 5 years ago. Oh. Yeah, that was like 5 years ago. Yeah, because freaking, bro. The amount of stuff that they offer here, crazy work. Crazy work. Crazy work. That's fire. I'm not sure what to do with this information now. I guess now that means I have to... I don't even know what this means, dog. I guess now that means... Bro, I have so much to do. Alright, I think I'm gonna... Hold on. I think I'm gonna end the stream because I have stuff to do now, for real, for real. But, I'll do this tomorrow. But now I gotta figure this junk out, for real. And I don't want to blast my FOSFA.